Hey, welcome back to Math with Patrick and Quill. Today is September 27th, and we're solving problem 270 from the Daily Epsilon calendar. And today's problem seems like a fairly standard arithmetic problem. We just need to figure out what the squares are of these two numbers, subtract the two, and then finally square root it. Although these numbers are kind of big, and I want to solve this in a silly way, so I want to solve this in a silly way. I noticed that this format, it reminds me of the Pythagorean theorem. Like whenever you solve the Pythagorean theorem, you do like a squared plus b squared equals c squared. Usually you're solving for the hypotenuse, but sometimes it's one of the original legs that you don't know. And so if you did want to solve for one of those original legs, let's just say b, I would first subtract the a squared to the other side, and then I would square root both sides. So one of the legs is going to be equal to the square root of the square of the hypotenuse minus the square of the other leg. And this format right here is exactly what we see here. And so using these numbers, it's possible that we could draw a right triangle whose hypotenuse is 123 and whose leg is 120. And we would just be solving for this last one right here. And one thing I do know about these kind of right triangles is that they're proportional to other triangles as long as you use the same scale factor to go between the triangles. And I do notice that both 120 and 123 are divisible by 3. So 120 divided by 3 is 40. 123 divided by 3 is 41. And so I guess this length right here would be b over 3. And this one, let me just call this a different variable for a sec. Let's just call this, I don't know, d. I haven't used that letter yet. To me, finding d is going to be easier than finding b simply because the numbers are smaller. And so we could try finding d by using that same idea where d is going to be equal to the square root of the hypotenuse squared minus the other leg squared. 40 squared, that's just basically the same thing as doing 4 times 4 and then tacking on 2 zeros. And then 41 squared is going to be pretty similar to 40 squared. I'm just kind of thinking of using kind of an area model for this. I already know that 40 times 40 is 1600. And so I'd need to add on another 40, and another 1. Or I would just need to add 81 onto 1600 to get what 41 squared is. And then subtracting these two is pretty straightforward. We just get d is equal to the square root of 81. And then I can do the square root of 81 in my head because I've done a lot of squares and square roots before. D is just 9. So if this is 9, we can work our way backwards now. I would need to multiply by 3 in order to figure out what b is. B is 27. And b is precisely the thing that we were solving for today because it is the square root of this squared minus that squared. So that's my solution. B is 27 using some knowledge about Pythagorean triples. Now we totally could have just evaluated 123 times 123 and found that kind of long number here and subtracted another number there. Finding the difference of those two, we would get whatever 27 squared is, right? Because we would have to square root it. Those would go away. We get 27 for the day. 27 squared should be 729, I think. But I don't know. I just didn't want to do all that and work with larger numbers, and so I used what I know about smaller numbers to help me get the answer today. So that's at least how I want to solve it. A little bit silly, but it worked out. So thanks for watching, and I'll see you tomorrow.